Assalamu alaikum student. Today we will start a new chapter that is tangent to a circle. Uh, Again, this chapter is related to circle theorem and basically it's related to tangent to a circle. So first of all, need to know what is tangent. So for this, I draw a circle at this point, and then I draw tangent through this point to a circle. So basically, tangent is a line that touches a circle on a one single point. Just touch a circle at one single point. That is called tangent to a circle. So what is tangent to a circle? A line that touches a circle on a one single point. That is called tangent to a circle. Again, I'm repeating it. A line which just touch a circle on a one single point. That is called tangent to a circle. Now, you already know what is tangent to a circle. So, our first theorem related to tangent to a circle is if a line is drawn perpendicular to radial segment of a circle at its outer endpoint, it is tangent to a circle. A line drawn perpendicular to a radial segment. Radial segment means line of radius. If a line is drawn perpendicular to radial segment of a circle at its outer endpoint, means the point that touches the circle. Then, if we draw a line, perpendicular line at that point, that line is tangent to a circle. So, how we can prove this theorem? Let's see. That is a circle. That is a center of circle and any point on a circle. That P representing any point on a circle. If we join A and B, that will become a radial segment. Now I'm joining A and B. A and B. Now this line is radial segment. So according to our theorem, if a line is drawn perpendicular to radial segment, means if I draw perpendicular line to this radial segment, it will be tangent to a circle. Let's see. I choose a perpendicular line through this point and to this line. Now you can see a line is drawn and it is perpendicular to radial segment because I selected the perpendicular line. So it is a perpendicular line that is perpendicular to radial segment and it is tangent to a circle. See that line is touching the circle on one single point. So it's a tangent to a circle. That line is tangent to a circle. That is our first theorem. So any line which is perpendicular to radial segment, it's a tangent line. We can prove this by measuring an angle. Let's suppose I mark a point here as C. Now, if you measure angle ABC, you can see it equals to 90 degrees. So, whenever a radial segment is perpendicular to any line, then that line is tangent to a circle. Means that line only touches circle on a one single point. That is our first theorem. Now, the reverse of the first theorem is that the tangent to a circle and the radial segment means if there is a tangent to a circle and there is a radial segment, the point of contact and the center are perpendicular to each other. Means if we join a tangent to a circle and a radial segment, it means that whenever we draw tangent to a circle, if we draw tangent to a circle and a radial segment, then they will be perpendicular to each other. That we already proved in first theorem. Now we will again see that in second theorem as well. Here you can see a circle with center A and any point B on a circle. If I draw tangent to that circle, so I'm drawing tangent to this point, to that circle, that is a tangent line, as it's touching a circle around one single point, and that point is P. And now if I join radial segment, you can see segment from A to B, and for confirmation, as this is tangent line, that line is tangent line, and that is the radial segment, you can say. radius line or radial segment. So according to our theorem, that the angle between these two should be 90 degree. So we will measure it and try to prove it. I mark a point C here and I'm trying to measure an angle ABC. You can see that that is equal to 90 degree. So it means that any point, any tangent and radial segment are always perpendicular to each other. That we have to remember. Tangent and radial segment are perpendicular to each other. Means the angle between them should be equal to 90 degrees. That is our first theorem. According to, again, I'm repeating the first theorem. If a line is drawn perpendicular to radial segment, means any line drawn perpendicular to radial segment is a tangent. And in its reverse theorem is the tangent to a circle and radial segment. If tangent and radial segment are there, then the angle between them should be equal to 90 degrees. So so these are the first two theorems and they are the converse of each other. So we have to remember radial segment and tangent line are always perpendicular to each other.